Hey guys, I just wanted to do a quick example for your assignment for the day in case you needed a little bit more help from our lesson video. So this is your assignment. It does give some background information. So on Lewis dot diagrams, it basically tells you exactly what we went over in our lesson in our own slides about how to find the valence electrons and also to draw the diagram. So this has a built-in periodic table that shows you the number of valence electrons, and it's going to actually be a really good help with doing these Lewis dot structures. So I'm going to do, there's also an example for you, so hydrogen's done, but I want to do, let's see, I'll do magnesium because magnesium's a little bit higher of atomic number. So let me click out of here. So this is just a review of 8-man as well as valence electrons, and then we're going to practice with our Lewis dot structures on the bottom. Okay, so the first thing we need to do is figure out the atomic number of magnesium, which we're going to do through the periodic table. Remember, you guys being virtual can always pull up p-table. If you just type it into Google, it'll come right up. So I'm going to come to my periodic table, and I'm going to find magnesium. And remember, the smaller number is the atomic number. So our atomic number of magnesium is 12. Okay, so 12 for the atomic number. Now the atomic mass, we are going to again get from the table because it doesn't give it to us, so we're not really worried too much about isotopes today. So the atomic mass is 24.305. We're going to round that to the nearest whole number. So I'm going to say it's 24 because 0.3 will round down to 24. The protons, remember 8-man, so A, atomic number, is equal to P, which is 12. And it's also equal to E, your electrons, which is also 12. Now remember our neutrons, that's the man part of 8-man, so atomic mass minus atomic number will give us our neutrons, because remember the mass is the protons plus the neutrons. So if we know the protons and we want to figure out the neutrons, we just subtract. So 24 minus 12 is going to be 12. So we're going to have 12 neutrons. And then for our valence electrons, we have to find the group number that magnesium is in. Okay, so remember the group numbers are the columns. So magnesium is in group 2, okay, group 2. So that means magnesium is going to have 2 valence electrons, right? Now it asks for the number of energy levels. Remember, the number of energy levels comes from the period, not the group. So magnesium is in 1, 2, 3. It's in period 3. So it's going to have 3 energy levels. Okay, so it's in period 3, so it will have 3 energy levels. So remember, valence electrons comes from the group number, energy levels comes from the period number. Group number is up and down, period is from left to right. So then for our Lewis dot diagram, remember we want to put the valence electrons around the imaginary box, around our elemental symbol, and we want to start at the top and then make our way clockwise. We want to fill 4 first and then another 4. Now we only have 2 valence electrons in magnesium, so we're not going to even have to worry about that. But just remember, as you guys are filling these, they need to be, you need to put your electrons on as a single first and then go back and pair them up. Okay, so since there are 2 valence electrons, I know I'm going to need 2 of these purple dots. I'm going to put the first one up here and then the second one right there. And that is your Lewis dot structure for magnesium. So you have 2 examples now, one that's built in right here and then one for magnesium right here. So you guys have to do carbon, lithium, boron, oxygen, and sulfur. So just 5 examples for you to do on your own today. Make sure you're using your periodic table. Again, if you just Google p-table, it pops right up. Make sure you're using your table to fill in the information and then dragging the dots to do your Lewis dot diagram.